This is a nice question about movement. It comes from the entrance exam for engineers, physicists and mathematicians into Flemish universities, and only 53% got this one correctly. So if you want to try this for yourself, you can pause the video, read the question and have a go at it. Alright, so the question is, an object hangs from a spring and moves up and down when the height h of the object is as a function of time t is given by h of t is 5a plus a times sinus omega t, with a positive constant and omega is pi over 10 1 over second, or second to the minus 1. Let d be the total distance traveled by this object between t equals 0 and t equals 215 seconds. And which of the following intervals does d lie? Right, so to get the speed of this thing, we'll have to differentiate this. So the differential of h to t gives us a cosinus omega t times omega, or a times cosinus pi over 10 times t times pi over 10. And then the distance traveled is the integral from 0 to t of the speed, obviously, but we'll have to take the absolute value of the cosine, because, well, if you don't do that over one period, this will turn out to be 0, so which is not the case, obviously. So we end up with a times pi over 10 times the integral from 0 to 10 of the cosine of pi over 10 times t dt, and the absolute value of the cosine. Now pi over 10 times t, that means one period is 10 seconds. You can easily see that if you add 10 seconds to the cosine. So you start off with cosine of pi over 10 times t, absolute value. That's equal to the cosine of pi over 10 times t plus 10, or absolute value of cosine of pi over 10 times t plus pi, and that's equal to the value, absolute value of minus the cosine of pi over 10 times t. Since it's an absolute value, these are equal. So one period of this thing is 10 seconds. Now for one period, we can have the integral of 0 to 10 of the absolute value of the cosine of pi over 10 times t. Now if we say that theta is pi over 10 times t, then we get d theta is pi over 10 dt, and dt is 10 over pi d theta. For t 0, we get theta is 0, and for t is 10, we get theta is pi over 10 times t, so times 10, so pi is theta. So we get the integral of 0 to pi of the absolute value of cosinus theta times 10 over pi d theta. Obviously, you cannot work with absolute values, so we'll have to split this one. For theta in the interval between 0 and pi over 10, cosinus theta will be positive, and for theta from pi over 2 to pi, cosinus theta will be negative. So we'll split that and just put a negative sign in front of the second one, sorry. So we get 10 over pi, we can just get that out. And then we have the integral from 0 to pi over 2 of the cosinus theta d theta minus the integral of pi over 2 to pi of cosinus theta d theta. So that turns out to be the sine of theta between 0 and pi over 2 minus the sine of theta between pi over 2 and pi. So 10 over pi times 1 minus 0 minus 0 minus 1. So that turned out to be 2. So that's 20 over pi. So the distance for one period is a times pi over 10 times the integral that we just got. So that's a times pi over 10 times 20 pi. You can see you can get rid of the pi, and 20 over 10 is obviously 2. So the distance traveled over a period is 2a. How many periods do we have? Well, we have t from 0 to 215. One period is 10 seconds, so 215 divided by 10 gives you 21.5. So the total distance is 21.5 times 2a, which we got here. So that's 43a. 43a, which is in between 40 and 50a. So answer C is here the correct answer.